Alright, welcome to video section point 6, solving equations with radicals. So the power rule for solving a radical equation is very similar to working with anything else with equations. So if both sides of an equation are raised to the same power, all solutions of the original equation are solutions to the new equation. Okay, so we're working with equations that have radicals in them, which is not something we've been working with before. Before, we've either been working with linear equations, so just x to the first power, or quadratics with x to the second power. Okay, so now we're taking a look at working with solving equations that have a radical in them. So square root of x, or once again, remember, x to the half power. Alright, so let's take a look at the steps for solving equations with radicals. And once again, this is also in your book, so hopefully you do read through the books and also try out the problems in the books as well. It's great practice. So step 1, isolate the radical. Very similar to when you solve a linear equation and you isolate x. In this case, we'd be isolating the radical, whatever inside it. Step 2, apply the power rule. This would be, if we have a square root, we're going to raise this side to the second power. And then whatever's on this side, once again, remember with equations, what you do to one side, you have to do to the other side. Yep, correct. Once you do that, and then they cancel. So that's applying the power rule. And then step 3, you're going to solve the new equation. So you'll end up with something squared, like that, which is a problem that we're more used to. This would be like a linear, or maybe it'd look quadratic, because we know how to solve these. And then step 4, you're going to check your answer. So because the original problem had a square root, remember, sometimes we cannot have negative numbers inside certain radicals. So you do need to check when you're solving something that was originally a radical equation. So let's take a look at example 1. Solve this for x. Be sure to check solutions. Now, one thing to note, on an exam, I may not tell you to check the solutions. That is something that you would need to remember yourself for radical problems, okay? This is just a reminder for this lecture notes. Alright, so solving this, the first step is to make sure that the radical is by itself, which it already is. So the next thing we're going to do is we're going to apply the power rule and square both sides. And then we get 9x plus 7 equals, and then 5 squared is just 25. And hey, this looks like something we know. This looks linear. We know how to solve this. We're going to go ahead and isolate x. And then we have 9 equals 18. So sorry, 9x equals 18. And then we're still solving for x, so we'll divide both sides by 9, and we get x equals 2. Once again, though, we have to be careful. This original equation had a radical, so we need to make sure that it works. So let's go ahead and show our checking. And once again, with the checking, because we don't know it's actually 2, go ahead and include my little question mark. So square root of 9 times what? Well, 2. We're checking if 2 works. Is that going to equal to 5? Well, square root of 9 times 2 is 18, plus 7 equal to 5. That's the square root of 25. Is that equal to 5? Well, square root of 25 is 5, which is indeed equal to 5. So yes, it does check out. Awesome, so we do have a solution. Now, if it didn't check out, what would we do? Well, we would cross out our solution and write no solution. And because you already show the work for no solution, you don't need to write a reason or an explanation down below. If you don't show the work, you need to write an explanation down below. Okay, but it does work, so we're not going to cross it out. We're going to go ahead and leave it boxed as x equals 2. Voila. Alright, let's take a look at the next one. Okay, so it's a radical problem. My goal, once again, first step is to get the radical isolated, which it is not. We need to get it by itself. So anything that is not in the radical will move to the other side. So these two things. So square root of 16 minus x minus 4 equals 0. Go ahead and get both of them to the other side. So square root of 16 minus x equals x plus 4. So now it's by itself. Now we'll go ahead and use the power rule, so we'll square both sides, because this is the square root. If it was a cube root, we would cube both sides. Okay, so cancels. And we have 16 minus x equals, ooh, careful. This step is where a lot of students sort of stumble. So be very careful. Focus on this for a sec. Which one does this equal? Does it equal x plus 4 times x plus 4? Or does it equal x squared plus 4 squared? Which one do you think it is? The answer is this one. It is not this. We do not distribute the 2 in. Why not, you might say? I thought that works. It only works if it's multiplication on the inside. This is addition. It does not work. So we have to put out the 2 binomials, okay? So please be careful when you see that. It may be tempting to distribute the 2, but you can't because there's addition going on. There's addition, so we cannot distribute the 2. If there's multiplication, we could. Or division. So that's x plus 4 times x plus 4. So 16 minus x equals x squared plus 4x plus 4x plus 16. We had to do FOIL. The 16s will cancel each other out. We have negative x equals x squared plus 8x. Now what kind of an equation do we have this time? It's a square. We have a quadratic this time. A little different than last time. But remember, we know how to solve quadratics. We're going to go ahead and set it to 0. And we get 0 equals x squared plus 9x. How do we solve this? Well, they both have a common factor of x. So let's go ahead and first factor out the greatest common factor. And then after this, notice they're both perfectly factored. So we can use the zero factor property. So we have x equals 0 and minus 9 from both sides. X equals negative 9. Okay, we're almost done. We need to check and make sure that our answers work. So let's go ahead and show the checking. So the square root of 16 minus, and we'll go ahead and check which one. Let's check 0. Minus 0, minus 4. We want to make sure if that equals 0. So it's my little question mark right there. So I have 0, 0. 16 minus 0 is the square root of 16. Minus 4, is that equal to 0? Square root of 16 is 4, so minus 4. Is that equal to 0? Yes, it is. 4 minus 4 is equal to 0. So 0 checks out. 0 is an answer. Awesome. Let's go ahead and check the next one, which is negative 9. So you might be worried and say, wait, we have a negative. We can't use it for radicals. But remember, it's not just if this is a negative or not. It's if it makes your problem not true or negative. All right, let's check negative 9. So check negative 9. Plug that in. Square root of 16 minus. I'm going to leave space to plug in that negative 9. And it should be minus 4. And we're checking if that equals 0 in the end. Once again, we're not solving. We're just checking if both sides end up equaling the same thing. So we'll plug in the negative 9. And we get the square root of 16 plus 9 minus 4. Does that give me 0? Well, 16 plus 9 is 25. I want to know if that equals 0. 25 is going to be 5. Well, the square root of 25 is 5. Plus 9 minus 4, is that going to end up equaling 0? 5 plus 9 is going to be 14 minus 4. Does that equal 0? Ooh, 14 minus 4 is 10. 10 does not equal 0. So, square root of negative 9 does not check out, but 0 checked out. I don't know why there's a check mark next to negative 9. Okay. So there we go. This would be extraneous. It does not work. Okay, so let's move on and check out the next problem. I believe this is the last problem for this section. Yes, it is. Ooh, this one is new. What's new about this? It's a cube root. Okay, so we're going to go ahead and solve this for x, but the same concept applies. Except you might notice there's something else to this problem that we haven't quite seen yet. There's a radical on both sides. How do we deal with this? Well, what we do is we just keep them on each side, because if we cube both sides, now we can end up getting rid of the radical. However, if I had tried to move both to one side, what would I have gotten? Let's say if I had subtracted the other radical to the other side, and then I tried to cube it. Remember, can we distribute the 3? The answer is no. Why can't we distribute the 3? Because there is a minus. Remember, plus or minus you cannot distribute over. So this means, if I was to try and multiply this out, I would need the cube root of 4x minus 5 minus the cube root of 3x plus 2 multiplied to itself how many times? 3. I would not want to multiply that out. That is why we're going to keep them each on one side of the equation. So much simpler to do that. I mean, if you want to try the other way, go ahead and try for it. I would be too scared to try that way. Okay, and those 3's cancel each other out. Nice and easy peasy. 4x minus 5 equals 3x plus 2. And look at that. We have a beautiful linear equation. Which means we'll isolate x. So minus 3x on both sides. Add 5 to both sides. And we get x equals 5, 6, 7. Are we done? Almost. We need to make sure it works. Let's go ahead and check our answer. So checking 7. So the cube root of 4x minus 5, does that end up equaling the cube root of 3x plus 2 when we input 7? So let's check it out. Okay, so inputting 7. That's going to be the cube root of, and 4 times 7 is 28 minus 5, cube root of 3 times 7 is 21 plus 2. So the cube root of 28 minus 5 is going to be 23. Is that equal to the cube root of 23? Well, the cube root of 23 is equal to the cube root of 23. Even though we don't actually know what the cube roots are, we know they're going to get the same answer. So, yes, this checks out. And x equals 7 is our solution. Alrighty, that is it for this section. Once again, if you ever have any trouble with the MyMathLab or any of the problems, please reach out and email me. If not, I don't know that you're struggling or that you need help. So once again, communicate with me, and I'll be glad to help. Communication is key.